have expertise in cooling technology. We know exactly how to properly interface, and this is another intellectual property that we have, and that's the interface between the solar cell, let's say the sun is shining on it, and the heat sinking material, where the excess heat, which is what 60% of the energy has to be dissipated, and we've done that by, in this particular case, of course, we over-designed the heat sink, and this
made up of aluminum.
That's right. This is just like a regular heat sink that you would find in semiconductors. And so even a mounting of a cell onto the surface of a heat sink, if you don't take into account the kind of material interfacing and how that's done, you still have a problem even at 2,000 suns. It would cause the solar cell material temperature to go too high. The efficiency goes down. In this particular case, we don't see any more than around 5 or 6 degrees difference between the ambient temperature and the surface of the
5 or 6 degrees is lukewarm, right? It's not, it's like a lukewarm water.
No, that does not affect the performance, because we're effectively sinking the heat away from the surface of the
and
solar
also
cell.
To compare ourselves, right? We already are converting out of the 100% of the light that's falling, 42% into electricity, right? Only 60% is to be radiated. Whereas other companies are only getting 18% efficiency. 100 minus 18, they have to dissipate a lot more, right? But they don't concentrate like what we do, and they don't get all the advantage out. They don't have to worry, but their output is very, very low compared to what we have, right? Here we get a lot more output for a given area and given acreage of the whole thing.
The final production design does not have this much heat sink on it. It's much less. You don't need that much. The whole profile of the unit is about this distance here,
including heat sink,
including the heat sink and all. And of course, everything is completely sealed. Every module is completely sealed. And all the interconnections are weather resistant, so that these modules can be plugged into a large array. Any size array typically would be panel size array, easy to mount on rooftops or whatever. So what Murthy was saying, a typical 48 inch by whatever size solar panel is.
48 by 48,
1 meter, let's say 1 meter.
Like that.
Multiple modules would be fit on that kind of frame. So it could actually replace essentially the shipping, and the size for installation is not any different than a typical solar panel installation.
To give you an example, because this produces 12 watts, we need about 84 of these modules to make 1 kilowatt. For a 1 megawatt, you need 84,000 of these small modules that we have to put together in a 1.5 acres or 2 acres, depending on the amount of sun that is falling. And to produce this because this is small, number of components are less, we can manufacture with the lowest common denominator laborers in India, right? That's the advantage. I was telling you, we are interested in hiring not necessarily already many certificates and degrees. Ordinary people can be putting together. What I'm saying, you can see.
This is what
very, very important.
Technology behind.
And we are committed to creating employment. We are committed to provide free training for them to do this. We don't charge them anything, and after they finish this, they can stay with us wherever we go. They can continue to on the manufacturing side and the assembly side. Even at the manufacturing, what we will do is, if we do it in, let's assume he was mentioning Chitradurga as an example, right? It can be any place. In that area, within a mile or 2 miles, we can create an assembly factory. The assembly is mainly three parts: the Fresnel lens that you see, which is plastic embossing, locally we can produce. And then the PC board is the simplest PC board in the world. There's no complicated electronics. Only 16 cells have to be mounted in this. And heat sink is a standard aluminum heat sink.
It's available.
And then this heat sink, as he very clearly identified, we have